Please go ahead.
Great. Well, thanks. And certainly yesterday there were a lot of great talks, and it's great to follow both Valerio and Ilke on this. So I'm just going to be talking about some of the environmental data sets that are accessible and that hopefully will grow into what's available in sort of the wired community. And this is work that Alex Jakes and Colin Johnson are involved with as well. So we've heard this concept of use-inspired research, that some of the pillars of wired are this: how do we involve data into it? Our particular effort is related to how can we actually handle some of the metadata associated with the data, as well as the data resources itself. And then as the project evolves, how to develop tools to be able to improve access to that. So Brendan, in his keynote yesterday, talked about this. It was, I mean, that's, it's great to hear the examples of what have been big events for the electrical grid in the West. So this is the case that he was mentioning, that July 10th this year was for the whole entire grid, that that was the peak demand. And this is kind of why. These are taking available data that I'll talk about and look at just what were the temperatures like that evening that drew all those air conditioners all over the West. So if you look at these temperatures, when you get into the purples, that means like the temperature at 9 p.m. was over 40 degrees C in Las Vegas, in Eastern California, and in particular also Redding, California. So for those in the northern part of the valley, and then it extended all along the West Coast as well. So one of the things as far as then grid resiliency is being able to adapt and use data on all spatial scales, here order 3 kilometers, and hourly data, as well as looking at coarser resolution as well. So how do we incorporate both past data, current data, future data? Some of the things that Ilke and Valerio talked about as well. And so I'll just run through a couple of examples here. So one thing is just to recognize, the role of the federal agencies that provide access to weather information for protection of life and property, and particularly the land agencies, BLM, Forest Service, parks, et cetera. And it's impressive. This is a lot of infrastructure that's supported across the Western U.S. And I'm sorry for the Canadians. I chopped part of wired off here. The same thing exists in Canada as well. So you can get a sense of sort of the number. How do you get access to that? Well, there's a variety of ways. You've heard about MesoWest, but really, MesoWest was research and development that's turned into operations through a spin-off company here, Synoptic, and Ashish Raval and Brock and Chris are here, and they'll have a table, I think, outside. So this is, anybody that works in a university environment understands that sometimes your IT departments take computers down. You can't run systems that are designed for protection of life and property and commercial applications from a university system. I'm sorry, it's just, those outages that your IT department does makes a big issue. So that's why we've transitioned that to that. And there's oodles of observations that are open access, including this. But what's really critical about this is the explosion, and why San Diego Gas and Electric is, this is really about Brian, as he's still here. There he is. Okay. There you are. I mean, he started this. I mean, it was, as you heard yesterday, it was really the vision of San Diego Gas and Electric to make sure that the data that could be used by other entities would be available, open access, for the National Weather Service and other applications. And of course, as disasters have happened, that's grown across the electrical grid. And you can get a sense of just how that is happening. And all of these through all, nearly all of these agencies are working through these utilities are working through a company, Western Weather Group, to collect that information and then distribute that. And those are available open access. So those are observation platforms, but how do you take that information and integrate it? Well, atmospheric science, we do data assimilation, we take a model sequence and then insert the data into it in terms of to generate an analysis. And so NOAA has an open data program. And so Google, Azure, AWS have tons of data available from agencies, including the National Weather Service. But that pretty much is from 2016 to the present. As a result of the interest of the land agencies to have a longer climatology, they ran one of these data assimilation systems starting in 1985 up through 2015 to kind of fill that gap. And Tim Brown here from Desert Research Institute has the one and only copy of that sitting on a NFS mounted disk, which is the whole point of Wired, is to not have single data sets, sitting on an NFS mounted system. So that's where, working with Valerio's group, that data will hopefully get transitioned over and find a home somewhere so that it's accessible, because that's going to be a very useful resource. But to be honest, nobody's really even had a chance to look at it. So the Wired community will be able to do that. Now, our particular aspect of this is working in the context of the open data program to use a operational model run by the National Weather Service, the high resolution rapid refresh. And that started back in 2014 as far as becoming operational. And here at the university, we became the only archive of that data in the early years, only because I had a graduate student who wanted to do a project. And we put it on a cloud archive here in CHPC, and that was kind of the initial archive for a lot of this data. So again, apologies to our Canadian contributors, but you can see that the dimension of the HER only slices the southern half of British Columbia and Alberta. It's sort of the continental US domain. In the future, there will be this larger rapid refresh forecast system, but it's kind of hit delays. The good thing about delays sometimes is that now, we're anticipating we'll be able to have a real-time-ish climatology of the HER going out several more years that will be pretty much frozen in its state. And part of that is, again, the kind of techniques that Valerio was talking about, taking the data and making it more accessible to users. In our case, we wanted to not have people have to download terabytes of data. So it's chunked into smaller pieces so that you can be able to just grab what you need through lazy loading type techniques. And there's papers that describe that. So let me just go through some examples. So, anybody in the West, you lived through our summer here, and, what is the impact? The kind of things, what can we use this information for? Where and when, was the electric grid really stressed by high temperatures? And that's why we need the feedback from utility side and all you EE folks as far as to tell us what are the conditions that are really stressful. But how many hours were the temperatures above 35 degrees Celsius? And especially during the evenings when the load goes way up. And then how does this look like relative to a recent set of years? And that's where this HER data set comes in, because 30-year, as we saw some of the presentations yesterday, things have changed over time. So comparing things to what they were like in the 80s and 90s is a little different. So being able to really focus on what's happened recently is important. Okay, so let's zoom in just on along the primary electric grid. I mean, it sounds relatively trivial to just determine the maximum temperature, but we're dealing with, thousands of hours of data and hundreds of thousands of grid points. The advantage here is by putting it in ZAR format and putting it in something that's accessible in AI, you can generate this kind of stuff in a few seconds, And so what you can see is, shouldn't come as a big surprise, those in Phoenix and Las Vegas, have really suffered. But I was in Boise when it was nasty, and those. But so how do you drill into this? How do you make it so that it's actually going to be somehow usable? So what about those evening temperatures? So if you just look at the evening temperatures, you can see that over 40% of the evenings had temperatures above 35 degrees Celsius, 95 degrees Fahrenheit across Arizona, Las Vegas, all that. But again, notice Redding, the northern end of the Central Valley. This is sort of that corridor, but again, look how Boise lights up. So, but if we use, but sorry to say, those people and probably the electrical grid know all about those high temperatures in Arizona and Las Vegas. They're used to that. But in Northern California, this was really an event where, the evening, just the temperatures in general during, this summer were, just much above what's normal. So just a quick summary, it's great to be involved with the other research teams that are doing a lot of these kind of use-inspired research. Hopefully some of these data sets will be useful. We'll be working to try to get them into whatever that collaborative environment is. And again, our focus is how can we kind of take this environmental information and make it more useful. And if you want further information, you can go to the webpage. So thanks.
Thank you.